Okay, everybody. So can you guys hear me? Let's see. Someone
Yep.
says yes. Wonderful. And so today I think there are some other students. They are not attending. Where are they? So for you guys, so I assume that you already submitted the exam paper, right? Do you?
Yep.
Yeah, cool. So yeah, probably we can have a small chat. So how was the exam? Simple, right?
No.
Any other answers?
It was very long.
Very long.
Yeah.
Yeah, I saw someone say fun. That's pretty good. Yeah. Now hate it. How come? So what's the biggest problem you think? If it's too long, too many questions?
Yeah, that was part of it. I probably spent a total of 24 hours working on that exam. And that's because some of it I don't some of it I had to debug, some of it I had to make
Yeah.
work with the new problems, different things like that. For me, it was too long. I probably spent about 24 hours on it altogether. I worked on it throughout the week.
Okay. So actually I intentionally doing this. So the point is that if we have too few problems, it's pretty risky, right? If you get some like one question wrong, then you will lose like maybe 20% of the points. I don't think it's good, right? That's why I think by adding more problems, we can reduce the risk of a single problem. So that's the kind of philosophy of it. Yeah, but again, this is someone said that it's you hate programming. That's true. So we do have a lot of programming in this one, right? Again, this is another kind of purpose of this exam. It's trying to push you very hard to to do some programming. And actually, I hope that after this exam, you can be very confident about MATLAB coding, right? I think that's this week could be some very intensive kind of work for some of you, right? So, for example, Zach, right? You say that you spend like 24 hours. So, are you happy about it?
No, because I had other projects going along with this as well. We have the project for this class, and then I have 3 other projects for different classes as well. So it was quite a busy week for me, and it's still continuing a busy week.
Okay. Okay. Oh, I think there are another comment that said that it's really hard and hope there will be some points for effort. Yeah, definitely. So when I grade all the things, as long as you have some attempts or you are trying to solve it, then this should be rewarded, right? I understand that some students maybe this is the first time to doing some coding, so I understand that one. So we of course we will have some points for again. I think if you try to solve it, you will get most of the points no matter the results. So that's that's kind of the thing, right? I cannot say that if your solution is wrong, then you get 0. No, that's unfair, right? So don't be nervous about the result. Achana says that you're nervous about the project. So in which aspect? You mean that?
No, I'm not nervous about it. I'm just saying we need to be working on that project, and then also I have other projects going on too. So having multiple projects and this take-home exam was very time consuming.
Oh yeah. I see that one. Okay. No, I mean.
I'm not very nervous about this class project.
Okay.
It's coming along okay.
No, I mean they're from from Achana. So Achana said that there's some like nervous about the project. Oh, you mean translate? Yeah, Achana said that translating the project to working code. So you mean how to implement, right? That would be the. So I think okay. So I think next week that would be our kind of a QA week for all the projects. So I will set up a kind of a time slot for each individual team, and that would be the next Monday and the next Wednesday. But besides that, so for example, after this week, you can actually schedule an appointment with me. Okay, from now on, so we can discuss your specific project and how to implement it. So I will give you some resource and yeah, of course, if you are kind of seeking some help for coding, yeah, I'm there. So you can ask for me. Again, so just email me for any kind of project related questions. So let's try to troubleshoot everything before it's too late. Okay. What's the demo day? The demo day should be the end of this month. Let me just try to see what's the timeline for this. Yeah, I think the demo, the presentation will be the April 27th and April 29th. That will be the end of this month, okay? And that's the only thing left for you guys. Again, if you are worried about the project, just email me. We can schedule an appointment and then we can, talk into details about the project, okay? Okay, so without further ado, let's start our today's lecture. Let me share our screen with you. Okay.
Question about the project: is there a report required with it?
Hold on one second. You mean we do have a report. So after the demo, yes. Oh, there's another thing you need to do. So
Okay.
pretty much during the demo, I will give you some feedback, right? So which kind of the item or which aspect you should improve, something like this. Then you can continue to polish your project. And then I think by May the 4th, so that would be the due date you report. So you need to put everything about your project in a single PDF, okay? And then trying to cover everything. So other people, I think the bottom line for this report is that if somebody else want to kind of duplicate your work, so your final report should be sufficient for them to start from. That would be the kind of a guideline for you to write your report. So pretty much include every details so that other people can duplicate. Okay, so that would be the things how to write the report. The report length doesn't matter actually, as long as you include all the details and things. And I think that that will be the report. Okay. Any other questions? We do have a report, right?
Yeah.
You're right. I
So
think.
with this report, do you want us to pretty much like almost add on to like what we have? So like obviously we had the proposal with some background and what we're trying to solve, and then we did a literature review, and then now we'll kind of do the conclusion and what we did. Do you want all of that in one document, or do you just want like a final report kind of with a simple background proposal, don't really dive too much into the literature review, just briefly touch on it and then give the results? Because that report will probably.
So the thing is that I will say everything. So just copy and paste. So copy the proposal, copy your literature review, and everything in a single report. Okay. And also for your slides, you can copy the figures and trying to explain in words, and that will be the way you can write the proposal. Okay. So pretty much that your proposal, your PDF, your report will be the kind of a very covers everything, I would say. Yeah. you can find all the details, proposals, the problems, the literatures, the methods, the results, and all your comments there. Okay.
Okay, thank you.
The deadline for presentation, that will be the end of this month. So you will present, we have 2 days, right? On the final week, that will be the April 27th and April 29th. So I think that will be the Monday and the Wednesday during the lecture time you want to demo. That would be the due date for presentation. For the report, that will be the next week after the demo. So that will be the May the 4th. Okay. So that's the 2 deadlines. Good. Okay, so we can start. Let's start. Let me share my screen with you. So can you see my slides?
Yeah.
Okay, wonderful. Let me just open this chat here. Let's see. Chat. It seems I cannot see the chat. Just 1 second. Well, that's weird. Anyway, if you have some question, maybe if I didn't respond, you may need to unmute yourself and speak aloud, because it seems I cannot see from the chat. That's weird. Can anybody just type something so that I can, just type something I can find where the chat is. Can you guys type yes or no, something like this? Just
People
type
are doing that. People are typing.
Oh, really? Let me see what
Yeah.
happened. Oh, I found it now. Okay, good, wonderful. Okay, so today that will be the kind of the second to the last lecture, right? That will be the lecture 20th. And for today, we're gonna cover 2 things. We need to review the exam 2. So we will review maybe spend 20 minutes to review the exams, right? So hopefully give you a very fresh kind of updating of the solutions so that you can have an immediate feedback on your solutions. And then we'll spend another maybe 40 minutes on new topic. It's about optimizations in machine learning. So that would be but this is a very brief introduction to this topic. So, okay, so let's talk about the first one. Let's try to review some the answers to exam 2, okay? So my way to do this is I will open my solutions, okay? So I'm using the Citrix. Just a second. So today we have about maybe 35 slides. So for the second topic, I need to maybe talk a little bit fast. So by the way, are you confident about your solutions?
Some of them, yeah. Some of them, no. It's so-so.
Not all. Yes, very good. Let's try to. Oh, that's so. Why it's so slow here? Just a second. It's weird. E. Where's the MATLAB? Let me read it. Oh, maybe a lot of people are using it, right? Hmm. Oh. And then something goes wrong. Oh yeah, it's here. So in this exam, we have 8 questions, right? About 8 questions.
Yeah.
Some of them are difficult. Some of them are easy, I think. I think for maybe 2 questions, you can directly use the code in the homework, right?
Yeah.
Okay, that's good. So I think when you say yeah, you mean you are kind of reviewing the, you have a very good preparation for this exam. So let's say for the first question, right? It's just so I have like about 35 lines of code trying to complete this kind of a question, right? Let me open the kind of problems, right? That would be exam 2. Where that one? Okay. So the first problem, right, is just to use f-min search, trying to solve this kind of a single variable problem, which should be easy. And let me let's see. Do you want me to enlarge the font, right? That's too small for you, I think. Let me just enlarge the font. Should be the size. Font size should be about this. Oh. Okay. Let me just first run this code to see what's the result. Okay. So probably let me just run it, and you can see this is the figure we got, right? Because in the first part, we want to plot the objective function over this range, right? So that would be something like this, correct? And then for the another, let me see. The second problem is trying to use f-min search to solve this problem, right? So which is, if we look at this kind of a, so for f-min search, the solutions is something like this, right? Minus 0.45, correct? Everybody get this number, right? Do you remember this?
Yeah, I think that's what I got.
Okay, that's good. So that's pretty much the solutions to this. And then for the third part, we need to use binary search to solve this problem, and without the first one, right? So the idea is that we need to skip the first one by setting the initial solution as in the middle, right? And also the delta x as the half of the range. So let's say this is a code, right? So you can see that my code is not really, it's very specific, just specific to this problem, right? So in this code, let's go through it. So the first line is trying to define our objective function, right? Which is defined in this kind of a code. And then we plot it. So this is a way to plot this over the things, right? So pretty much that we have an x, and also we put the x. We plot, this is how to plot a curve, right? X and y. The y is the objective value of it, correct? And then we use f-min search trying to solve it. So the syntax to use fmin search is you put the function handle to assign as the first parameters, and then the second parameter will be the initial guess. So we can put any number actually. So we put 0, right? So then it will return a solution. So that would be the second part. So for the third part, we're trying to use binary search to kind of solve this problem. So the initial x star is 0 and the dx will be 3. For this chunk of code, so actually you can find the sample codes, right? It's very standard. And the only thing is that for each iteration, so if you look at here, we have an iteration, right? The total number of iteration is about 20, right? And then in each iteration, we have a fprintf so that we can print out the solutions, especially the x star. And then if you look at the output here, that's output, right? So all the solutions are displayed. And then it's done. We just kind of screenshot this guy and copy paste the code. Then the first problem is done, right? Should be easy, right? Any comments on this? Good. So for the second question, is talking about using marching grid to minimize this problem, correct? I think this problem, let's say, I think it's just a homework, right? If I remember correctly, homework or kind of examples from the lecture, right? So you simply use the marching grid code trying to solve this problem. But here we need to run 20 iterations. And also we need to plot, if you look at this, right? What's going on? If you look at this, plot the following in the single figure, right? So the contour and all the solutions. So that would be the problem. And for the code, if we open the code 2, that would be the code. Again, let me just run this code, trying to see what happened. But before that, let me just clear everything and clear the screen, right? So that you can see what happened exactly. So if I run this Q2, there's nothing output, right? That's weird. But you can see here, this is the result. I hope everybody get this figure, right? Do you?
Yep.
Yeah, so there's a kind of a comment says that in this problem, I didn't ask you to check whether the grid is moving or not, right? No, I don't ask for that. So I only want to know that the 20 iteration solutions and give this kind of plot. If you get this kind of a plot, then you are good. So pretty much you can get all the points. So that's the idea of it. Yeah, I hope everybody can get this kind of very beautiful curve, right? So that's the idea of it. So you can see this is how we use marching grid to get the final solution. So that's how we put the code in use. Okay, I think this problem should be fairly simple. But here I have, if you look at the instruction, right? I intentionally tell you that we have 21 points, right? Including the very first initial solution. And also for each point, you need to mark as O, right? So probably I need to go through the codes so that we can have a better understanding. So for this problem, for this marching grid, as usual, we define the function first, right? Again, when you define a function, this kind of a dot operation is very important. You have to do this. And then the following code, this is trying to, just a standard marching grid, right? You can just copy paste the marching grid and the x star, y star, and dx, dy. And then I think this bunch of codes, you can directly copy from the sample codes, right? The only thing different is, let's say, I think for me, I actually use a kind of OR X, this kind of things to record each iteration's solution. So let me just debug, trying to show what happened here. So for example, if I run it, okay, if I run this code, you can see that the OX means all the 21 solutions. So OX and OY, they're currently just one solution, right? Because we only have one initial. And then let's run, we can run the kind of iteration, right? Because in matching grid, we have to evaluate 9 points, right? So we formulate the 9 points first, and then evaluate all the 9 points, right? They will give us 9 kind of objective values. And then we figure out which one is the smallest. And then we can actually update the best solution, right, among these 9 points. So that will be our updating. And after we determine, this is the end of the one iteration. So at the end of each iteration, for me, I pretty much add this solution to the OX. So you can say for now, OX is just one value. But if I run this code, it will become 2 codes, kind of 2 numbers, right? Because the newly generated code or newly generated solution is appended to this kind of OX. So similarly, for OY, for now it's just a single number, but I append the current Y star to it. So that would be the 2 values. But again, you can have some other way to record. You can simply, for example, just output it and then just manually record. You can just write down and then you can plot it. That's fine with me. Okay, it doesn't matter to use whether you use automatic code or use any other kind of methods. As long as you can plot the figure, then you're good. I don't care about the implementation. Okay, so that's it. And then in this code, let's just run. So I click continue, so it will continue to this kind of a line, right? So pretty much that we have run 20 iterations. So you can see that OX, it already has 21 solutions, okay? And then I plot it. So the idea is that firstly, we plot the F contour, right? Because you're asked to plot the objective contour first, correct? And then we need to plot all the solutions, and the solutions will be marked as a kind of a circle, and also it will be connected, right? So that's a kind of this is a command to complete the plotting, and then we can regulate the plot range. So that would be this, okay? So finally, we can get this result. So that's it. So let me know if you need some further explanation later, okay? So let's go to the, let me see, do I have any? There's no chat. So let's go to the question 3, right? For question 3, there are some, a couple of questions from you actually. So for this problem, you can say it's a fitting problem, right? That the context is that we're trying to predict the number of positive cases, right? Given the historical data. So for the day, that would be X, right? We have a couple of days recordings, and then their corresponding cases, right? So in this kind of problem, so again this kind of is just the context. You can ignore it, right? But the idea is that we're trying to use a very simple model, right? This kind of we can call it logistic model. Trying to use this model to predict the overall curve, right? And for the kind of predicting, we're converting the fitting problem into a minimization problem, correct? So this actually is called regression. So we'll talk about that later. It's kind of a regression, right? Given this kind of data and the model, we're trying to minimize the least square, right? So you can say for each term, it's pretty much that for each observation, for example, here, the first day, that would be the day 30, and also the number of cases is 2000, something like this, right? So we put these kind of two values in the model, right? Again, this is the observed data. And this formula will compute the kind of, a predicted data, right? So we want to minimize their errors. So that's the idea of it. But essentially that we have this kind of a minimization problem, right? This is objective. You will have about like 8 terms summation, right? And the unknown are just ABC, 3 things, right? And for your reference, I actually listed like 3 very representative values. So hopefully at the very first stage, you should get this kind of numbers correct, right? And then you're asked to use f-mean search to find the solution, right? So that will be the idea. So trying to output the solution and also trying to plot the data and the curve, correct? Let me see any questions from you guys. There's no questions. Okay, let me just run the code. So that would be question 3. So this is I only need like about 16 lines of code to complete this problem, right? Let's just run it. So I hope that everybody gets this kind of curve, right? You guys got this? Good. So for this kind of a curve, you can see that the curve is kind of S curve, right? S shape, like tiny S. And also you can see that the kind of a circle, they're representing one kind of samples, one data, right? I think from this kind of curve, I would say this curve actually fit the data very well, right? Pretty much very well. But you can say the maximum number will be, kind of 4.5, about like less than 500,000. But as we know that this number is too kind of underestimated, right? About the real case, right? For now, I think it's more than 500,000. But again, this is a kind of prediction. The model is there are many explanations for this kind of, inaccurate prediction. So one is that the model is not good. That's a very obvious one. So for another one is that there might be some kind of unreported cases and they are suddenly reported, right? Something like this, or the policy somehow is not strong enough, something like this. So there are many kind of explanations to say this, right? But again, this is how we use the very maybe 2 weeks goals data to predict like 2 weeks later, right? So that would be some error about it. Let's come back to the code itself. So the code itself, the first 2 lines here, right? I'm trying to define the data. I just copy and paste the table, right? We have the date and the number of cases. And then I split the data into X and Y. X will be the date, Y will be the number of cases. And then, so here's the next line here. This is how I construct the objective function. So some of you may have different ways to do it, right? So I think this is a very compact one. You can directly, input the model here. And in the model, X and Y are just, kind of a vector, right? And then you can do the summation. Then you can directly do the, everything, correctly, right? But there's another way. So another way is that you can actually for each data, for example, for the day 1 or for the day 30, right? And also this kind of the first data, you can have 1 term. And then you can have here you can plus, right? Here you can plus the second term and third term, right? You can manually code the 8 terms and add them together. That also works, okay? So that's another way to do it. And then I, input like 1, 1, 1 just to benchmark, right? I think this is a number I got, and this is another number I got, right? That will be that'll be the kind of a benchmark data. So if you want to see the more digits, then you see kind of a format long. And then if you format long means that it will show all the things. So that will be, you know, everything will be displayed. So that's the idea of it. And then you are asked to use F-min search to solve this problem, right? So here are some kind of tricks, right? In F-min search, there's like we have ABC, we have 3 parameters, right? But for F-min search, the syntax is that we only have one X. So you have to assemble ABC into a vector for, you know, kind of X, right? X is a vector. So by doing so, we can use F-min search to solve. Then the solution, we can get and then the solution will be a vector of 3 values, right? Let me see if I type solution here. So you can see that I have 3 values right here. And then you can deassemble them into ABC, right? That's something like this. And then you plot it. So for plotting, that's something like very easy, right? So plotting first in the figure, just generate figure, and then you plot the, you know, the sample points, the data, right? X and Y. So for here, because I didn't put a kind of a dash here, right? Then the report will be just some points, correct? So that's how I plot the kind of points. I also put this kind of things in the manual, right? In the last lecture. So how to plot different points. And then if I want to plot the curve, so what I do is that I will generate a series of different numbers, right? And then I plot it, and all the kind of numbers, they are connected. Let's see. I think that would be something like this, right? It seems that this code is not that correct. So I think it's correct, right? Is that correct? Maybe you need something like this. You need to say that they are connected, right? You can, you know, enforce that they are connected. But anyway, as long as you can get a kind of a figure like this, then I think you are good. Okay, so any comments about this problem? Okay, wonderful. So let's talk about the next problem. The next question 4. Here we have 20 points, right? That's a lot of it. But actually, this problem is somehow fairly simple, right? Because we have the codes for this kind of things, right? In the lecture, I think comparing, I forgot which lecture, but I have this kind of code by trying to compare the 3 different algorithms, right? From the SD, the CG, and the Newton's methods, right? So for the 3 methods, the only thing you want to pay attention is they are starting from different initials, okay? So for example, the first is starting from 0.1, 0.1. The second is, there's a minus, right? There's a negative, so just be careful about it. Then you can plot all the 3 things in a single figure, right? That's the idea. And the context of this kind of a minimization problem is, so we want to find the complex root of this function, right? The cube minus 1. So we want to find the kind of complex zeros. And for a complex zero, it's pretty much that it's A and B, right? So A is real, B is imaginary part. So for this A and B, you can actually, but if you can double check whether this computing is correct or not, whether they're correct or not. But anyway, this is the kind of function we generated, right? So we want to use this kind of 3 algorithm to solve it, correct? So for this, simple but long. Yeah, this is a very simple problem, but it's very long. So I spend it, you know, it's this kind of thing spend me a lot of time trying to, you know, put up some problem like this, right? It's long. I agree with it's pretty long, but let's look at the code. For the code, I think the code, yeah, it's very long. It's about like 150 lines, right? The code is very long. So But let's just run and see what's the result. Okay, that is the result. So how many of you get this result? Okay, good. I say, yeah, something like that.
It looks like your conjugate gradient isn't working great, right?
Conjugate gradient, this one, right?
Yeah.
Yeah, it's not great. Yeah, that's why I figured out that this is a very good kind of a counter example for conjugate gradient, right? Because we spend a lot of time, but the solution is still kind of derouting, right? That's my solution. How about you guys? So Zach,
I had that at first, but I didn't think that was correct because I saw that over there that was most likely the that there was like the circle over in the top left. I figured that was a minimum based off of the graph and the contour. So as soon as
yes.
mine did that, I figured something was wrong with my code. So I went back and I got it to work to come to that point where you're on right now.
So you mean you change your result is different?
Yeah, it goes to that center point there because, like I said, I thought where that was going was not
But how
correct.
come? What kind of thing to change? You can make it there.
Well, I thought there was errors in my code, so I went back and made it work. And then I forget what it was that I did. I think it was with the beta calculation or something.
But anyway, yeah, this is a kind of minor. It's kind of minor problems. Okay. Yeah. Oh, probably that's very good. Yeah. I think that again, it's yeah, that's a better way. Probably the beta. I would yeah, I would double check your solution and trying to see what happened there. I mean, as long as you can like explain what you're doing, and then fine with me. So again, if we are using the way in our lectures, right, trying to the way we are talking about in the lecture, so that's the result we got. And also, if you look at the if you look at this kind of a hint, right, the reason is that because I never expected that this kind of conjugate gradient is so inefficiency, right? So so that's why I add something like this, right? Trying to warn you that if you got something that's weird, then don't be surprised. But again, if you get some other ways, then fine. I will double check it. But the thing is that I think most of you will get this kind of solution, right? So if you start from here, you get this guy, start from here, you got this guy, and something like this. I think this kind of is a good way to compare the different algorithms. And again, this is a kind of a three complex zero for the problem, right? Because in our problem, it's a kind of it's a polynomial with order 3. So for this kind of a polynomial function, it will have three complex roots. So that corresponding to the center of this kind of three contours. Okay, so that would be the idea of it. Let's say, let me go through the codes. It's too long, so probably I will not really explain them in detail. But again, I think you can easily find the sample codes, right? And then you can modify it. So the idea is that you just implement the three different algorithms starting from different initial points, and then you can plot it. I think in my sample codes, you may have some maybe some other kind of legends or some other stuff or other terms. So don't worry about it. So as long as I can see that you have this kind of a pass, then you're good. Okay. So don't worry if you have some like extra terms on this or even 3D. That should be fine as long as I can see that this kind of three passes. Okay. Your plot looks so elegant. Yes, so yeah, there is something like from Tana says that my plot seems very clear, right? But yours is kind of messy. But it depends on how. There are several kind of tricks. So number one is that for the contour step size, right? I hope that you can follow this kind of if you look at the instruction, right? We want to set the level set as 0.2, right? If you set the level step at 0.2, then you will get a similar contour of this one. Okay, that's the contour wise. And for the plot wise, so my the line width and the marker size is by default. So maybe that's another different way, because in my sample code, I think I have some like assigned the line width, right? Maybe the line width and the marker size are kind of assigned as different value. So you may have different line widths. Sometimes your line maybe is bolded, so that's maybe the one reason to looks very messy. Another one is that you may have some like legends here. But anyway, as long as I can see this kind of three passes, then you are good. Okay. So in the plotting, so pretty much here, this is how I do the level step, right? In our sample codes, we don't have this kind of a level step, right? We just F contour, the function, and the plot range. But here we have to assign or have to specify the level set so that you can get a good plot, okay? So that's the idea of it. Okay, so if there's no further question, we can jump to the question 5. So for question 5, you're asked to use fmincom to solve the problem, right? So fmincom is the MATLAB building function, right? So for here, the objective is very kind of a complex. So the first thing is that you should make sure that these two numbers are correct, and then you can use fmincom to solve it. And when you solve it, you need to plot the three things together. So one is the contour of this function. Another one is a boundary, right, of this kind of a circle. And the solution, just one single point. So let's just run this kind of things. Let me close all the, when you say close all, so pretty much MATLAB will close all the figures. Okay, so let me just close all. You can see that all the figures are kind of closed. And then we can run the question 5. Yeah, this kind of a code is pretty short, right? Let me just run the code to see the result. So this is the result, right? We have a kind of a contour like this, and also the constraints, right? A circle, and the solution is something like this. How many of you get this? Okay, that's wonderful. So yeah, this is the idea. Great. Yeah, so this is how we got this kind of a figure. The idea is that we need to use fmincom to solve a constraint problem, right? So for the constraint problem, we need to define the objective first. So this is the objective, right? Right, as usual. And then in the fmincom, the syntax is we have to use just a single impulse, right? So we have to assemble the xy into a kind of a vector. So that's the one trick you have to deal with. And also there's a 1 and 4. I don't know who remind me that I forgot this kind of initial points. Actually, it's very important. We have to specify the initial point, right? That's 1, 4. And then the last term is that you need to put your constraints, right? So your constraints will be specified at the bottom, right, as a helper function. So for the fmincom, the syntax is you have to output the less equality constraints and the equality constraints. in this problem, we don't have equality constraints. So that's why we have an empty, right, to assign to the equality constraints. But for the less constraint, it's a circle, right? If you look at this kind of a constraint, right, x squared plus y squared minus 1, that will be this one, right? So again, this x is just a vector, right? Because in almost all the MATLAB building function, they are just a vector, just a simple single vector, okay? And in this vector, we have two elements. So that's the way we define the kind of constraints, and then we put it there. So after we run it, so let's say if I put it, let's debug, right? And then if I run it, I get a solution. So the solution is, because we have two, right, x, y, right? So that would be the minus 0.7 and the minus 0.7. That would be the solution. And this couple of lines is trying to plot the three things, right? One is we want the contour, right? So this is the contour, and then we need to plot the function. So for function, actually, for me, I have a kind of a cheating comment. It's called easy plot, or you can plot it there, your circle. But anyway, that's, I can, kind of have an easy plot. I can plot this guy. And also the, oh, where's the starting point? This is a solution, right? I plot a point, and then I set the plot range. Otherwise, it will look something like this. So I plot, then it will get something like this, right? Any questions? A color bar would help since the answer. Yeah, I think James is point out a very good question, is that if we have a kind of a color bar here, we can see that more rigid. What do you mean by rigid? You mean it's more like, oh, mine seems like it's not a circle, right? It's kind of like ellipse, I think. So you mean rigid means like more circle? Yeah, I think that's, yeah, I think, yeah. And then says that it's because of the ratio, right? Doesn't matter if you have something like this or this, then both are fine with me. And yeah, I think James talked about the color bar will help. That's very good idea. So you have a color bar, we can see that this color is kind of a smaller one, right? And the center will be a larger value. So we want to minimize around within this circle. So the best option will be this, right? Because all the points here are high value, right? So only on the boundary we'll get a smaller A value. So that's a kind of explanation for this problem, right? I totally agree with this. You have a color bar. Again, you can decorate your output, your figure, within like X, Y, and like the title, the color bar, or some other stuff. So as long as it looks very good, very clear, I think. Clarity is the most important. Okay, if we don't have any questions, we can switch to the next problem. That would be the question 6. So for question 6, it's a kind of a variation or kind of a variant of the knapsack problem, right? So in the original knapsack problem, for each type, we only have one quantity, right? One item. But here in this problem, for each type, we will have multiple quantities. For example, we will have 3 items of this kind of, have 3 items. We have with 3 and the value $7. Okay, so that's the let me see. So that's the kind of setting for this problem. So the only difference is we have some quantities, right? So for this problem, I hope that the overall instruction is self-explained, right? For example, here, I have one hint for you guys, right? So basically that this problem, if one type of the items have n quantity, right? We can manually divide them into n different items. For example, here we will split this kind of a 2 quantity into 1 plus 1, right? Then if you add up all the quantity together, that will be 11 items in total. So you can directly or manually, construct another kind of a table for this kind of weight value table, which has 11 columns. So that's maybe the easiest way to do this, right? And then you can directly use our previous codes, right? Because our previous codes can solve the problems if you have a kind of weight value, right? And each one have one kind of the quantity 1, correct? Okay, good. So for the table, again, this problem is that from this kind of optimal table, so we're trying to find the decision variables or kind of trying to find decisions for each item. Do we need to pack it or not, right? So we will have 11, 0, 1 kind of decisions. And the third problem is that we want to group that similar items together, and then we can know for each type how many quantities we want, right? I hope that this problem is clear to you. So let's just run the code. This is question 3 or question 6. So for this one, let me just run the result, run this kind of code. What happened? It seems that there's no plot, right? Oops. But I can, let's see. Hold on, let me just rerun this. Let me just rerun this guy. So this is the first part, the optimal table. You can see there's a lot of stuff here, and just copy paste, and the final answer will be 33, right? I hope that your object, the optimal solution or the optimal value is 33. So how many of you get this? The 33 guy. Yeah, it was good. I hope that some of you get this. Good. And then for the second part, we want to have a decision for each item, each individual item, right? We have 11 individual items, so there will be 11 1-0 decisions, right? I think you may have very different decision values. So because for this problem, it has many different optimal solutions. Although their objective has the same $33, but the decision will be different. I think I know at least 2 solutions. So here's one. So as long as your optimal solution value is 33, I think it's good. And this is a kind of one solution for it. And also this want to group, right? We want to group the kind of 11s into the 5 types or 6 types. Then that would be how we group it. For the code, I think actually for my code, I use something very different. Pretty much this code can automatically find or trace back the solution. So without using our naked eyes to figure out the solution. So for this code, I can directly find the solution, find the decisions. So let me just run this. So for example, this is the weights and the values, right? This is defined in the table. Let's say, it seems I don't need it. Hold on. This code are redundant. Sorry about that. So this is a table information, right? The weight, the values, and the quantity. So if you look at here, that's the weight, value, and the quantities. And if I want to expand this kind of a table into 11 individual items, you can do manually. But for me, actually, I use this kind of command. It's kind of repeat element-wise. So which means I will repeat the weight element-wise by 2 times, and the second term by 3 times. The 5 this kind of term by 1 time. Okay, that means repeat the matrix element wise. Okay, and then the result will be, if you look at here, it's a 11 kind of elements, and they are the same. You can manually put it here, but I mean, for me, I just use this kind of code to complete this kind of idea. And then the following are same, right? The idea, but here we need to modify this kind of a number, right? The how many items, 11, and what's the capacity, that's 14, right? So we need to change the number correspondingly. And after that, we will get the, this chunk of, iterations, we can just copy from the sample codes. And then we run it, we can see that our optimal solutions, right? So that would be the kind of idea of it. And then here I actually write this chunk of code trying to find a solution directly. I will not explain about them, but you can try to understand it. If you need some explanation, I can talk about this later. But the idea is that it's similar as our human to find the solutions, right? Probably let me just explain. The idea is that we trace back from the last item, right, 11th, and from the last capacity, 14, right? If this kind of the last item and the bottom right cell, right? If the last item with the maximum capacity, if that value, the 33, right? That value is equal to the value above. This is a value above, right? Means like the above rows. In this case, so for this kind of 11th item, right? We don't pack it because it's same, right? There's no change. That's the first kind of branch. And then if else means like if it's not equal to the value above, then actually, for example, here, if this kind of a value, so let me show you what does mean. What do I mean by the value? Where's the optimal data? If you look at the optimal data, I apologize. Optimal table. So this is our last kind of row, right? The value above is this guy, because it's 33 and 33, they are same, right? So that's why we don't pack the first item. And then we move up. We move up until this point, right? Until this kind of term, it's different. Then we can jump to the second kind of condition, right? If they are not equal, then we need to pack the current item, and also the capacity will be reduced by the weight of this kind of item, right? So that's the idea of it, because we already packed it. So the capacity will be reduced, and then we can continue. So this is the kind of the basic logic. So we just repeatedly conduct this guy, and until like the very, you can see that the I will only run to the second, the second item. For the first item, there will be some like a special corner case, right? Because there's no value above. The value above is actually 0. So that's why I compare this guy with 0, right? So that's a corner case. So for that corner case, if we have capacity and also it's not 0, then we need to pack the first item. So that's how we do this kind of coding. Okay. So by doing so, I can actually, using code to figure out a solution. So you can take a look at that one. Again, so we need to group the same type of items. Here, I also use a couple of codes trying to do this job. You can take a look, but I will just ignore it. But trust me, this is a kind of a correct answer. We can get the solution, okay? Any comments on this? Do you guys have any questions? Okay, seems very straightforward, right? And then we have the question 7. So for question 7, so the thing is, again, you're asked to use a built-in function called the integer linear programming, right? And this kind of a problem is fairly simple, right? Because we have this sample codes, and then we just extract the coefficient and form a vector, right? And put that numbers in the MATLAB, and then we can get the solution. So let me directly jump to the solution, question 7. So for question 7, here's you can see that I even copied the comments, right? So because it's really just very straightforward. So here, in this kind of, if I want to use the linear programming, right, the integer linear programming, I have to input this chunk of information, right, the function, the constraints, the equality constraint, and also the lower and upper bounds, right? In our problem, this is a 1, 2, 3, 4, 5. That would be the objectives coefficient, correct? And then A, that would be the constraints kind of coefficients for the left hand. This is so you need to complete the like x4 and x5, and here x1, x2, right? Because that coefficient is 0, so you need to know that one. And then we can have this kind of a coefficient table. And for B, that will be this kind of different values we put it here. And for the lower bound, because we see that they are positive integers, so which means lower bound will be 0, and upper bound will be, there's no upper bound, right? And also for the integer constraints, that will be 1, 2, 3, 4, 5. All the integers, all the unknowns are integers, right? And then we can just put here, and then we can solve it. Here I use fprintf to have a nice output. So if I run through this kind of a problem, I can have this kind of a solution, x1 equals to something like this, right? So that's pretty nice. Is that good? I think I forgot 4 and 5, right? But the solution should have 5 numbers. So here, this is 5 numbers, right? 4, 0, 0, 10, and oh, right. So do you got the same number here? Let's see. Okay, wonderful. So finally, we have a last question, right? So for the last question, that would be, let's say, it's again, this is just a homework. I directly copy here, and do I change anything? Yes, I changed this x. So in the problem is x squared plus y squared, but here I have x the force and the y force, right? This is kind of a that's the only difference. And other than that, this is just purely the homework, correct? I hope that you can remember this is purely the homework. So which means you can directly copy your solution and just change the 2 to 4 and everything is done, I think. Right? Yeah, so that's simple. So you just copy the code and change the objective function from 2 to 4, and then you will get this kind of output. Everybody should get this one, right? Let me know, everybody should get it. So wonderful. So it seems that we only have 5 minutes left. And so that's, yeah, so I think I should agree with you that it's too many questions, right? It even spent me like one kind of lecture to talk about the solutions. But I hope everybody can get some kind of exercise, right? So that would be the kind of solutions for all of it. I will, again, I will upload the codes and also I will upload the solutions. So just like a homework, right? So you can have a, detailed study, or you can run the codes if you have a different solution, try to see what's going wrong, okay? So that would be the plan. And we still have 5 minutes. Let me show you how many codes, how many slides I have. So we are at this slides, page 2, right? We have 38. So which means this is impossible to, kind of pour this kind of information to you guys. So I decided to, we can talk about this later, right? So we have, I can have 2 options for you. Which one you prefer? Option 1 is that I will record this lecture by myself, okay? And then on Wednesday, we will talk about another stuff, which is optimization in manufacturing, pretty much in 3D printing. So we have 2 topics. So I will record this kind of a machine learning by myself. And on Wednesday, we talk about the 3D printing with you guys. Another option is, so on Wednesday, we can talk about both topics together. But I may need like extra 15 minutes to do that. So which one you prefer? You want me to record a separate lecture and then it's option 2, right? Okay, so we can have some first option. Oh, there's some like let's just vote. Let's say how many want second option. Second option is both on Wednesday. First option will be I will record by myself, and on Wednesday we only talk about the 3D printing things. So that will be option 1. 1 or 2? 1 is 2. 2. Okay, let's vote. Okay, that's good. It seems like okay, most of you guys prefer the second option. So okay, I will have a okay. I think D-Line is talking about a proposal, says that everybody will get a bonus point for every minute we go over. That's yeah, let me say, okay, but what if I finish everything before the deadline, before the the time, right? Then you will get some deduction. But that's a good idea. So we will do both on Wednesday, and I will try to organize myself better, and so that we can complete everything. Okay, so that will be it. So okay, everybody. I hope that you enjoy this kind of exam, really. So it's not my intention to really, kind of challenge you or kind of I hope that you can really learn something from this kind of exam or this kind of lecture by, really implementing the code, give you a very intensive kind of, pressure, right? So that you can really try to push yourself very hard. That's my kind of, my hope that you can learn something. Okay, anyway, if you are kind of get hurt by this exam, just let me know and probably I will say something good to you. But for the grading, I hope I will finish the grading by the end of this week. And again, I will consider the efforts, of course. So because for coding, I know that you will maybe only need 1 more minute, right, to debug everything and to correct your debugs. But you already spent 2 hours on it, right? And I totally understand the coding styles. So even if you get some wrong answer, so don't worry, you will get most points. Okay, so that would be the kind of a grading policy about it. Other than that, I think I'm good. So I think I will talk to you on Wednesday. Okay, I will buy you like maybe 10 minutes more. Good. So that will be the end of today. Okay. And I hope everybody can, have a wonderful evening. Okay. Okay, see you guys.